Good evening and welcome to this session number 19 from the chapter of Heat and Thermodynamics. The topic is the zeroth law of thermodynamics, and based on this topic I have written here one point which basically describes the zeroth law of thermodynamics. So this is the definition of the zeroth law of thermodynamics, and this is one figure here which I have made in order to explain this zeroth law of thermodynamics. So as per the zeroth law of thermodynamics, if a system A, this is a system A, if it is in thermal equilibrium with another system C, and if there is another system B which is in thermal equilibrium with the same system C, then the system A and the system B will also be in thermal equilibrium. Now let us understand this with the help of this diagram here. So here there are two systems A and B which are separated by this adiabatic wall. Now this adiabatic wall is a barrier which does not allow the transfer of heat and mass. Now this system A and this system B, they are separated from this system C by a diathermic wall. Now diathermic wall is a barrier which allows only the transfer of heat. So after some time, what will happen that this system A and this system C, they will be in thermal equilibrium due to the transfer of heat, and at the same time this system B will also be in thermal equilibrium with the system C because of the transfer of heat. So if when this system A and system C, they are in thermal equilibrium, and when this system B and system C are also in thermal equilibrium, and if I remove this adiabatic wall, now then there won't be any heat transfer between these two systems because they are also in thermal equilibrium as per the zeroth law of thermodynamics. So if there is a system, say A, which is in thermal equilibrium with the system C, and if there is another system which is in thermal equilibrium with the same system C, then both these two systems which are in thermal equilibrium with the system C will also be in thermal equilibrium. So initially I have separated these two systems by an adiabatic wall so that no heat and mass transfer can take place. Whereas I have separated these two systems by a diathermic wall so that the heat can transfer from the system A to the system C or from the system B to the system C so that they can achieve thermal equilibrium. So once they achieve the thermal equilibrium, and after that if I remove this adiabatic wall, then there won't be any heat transfer between A and B. It means that which justifies the zeroth law of thermodynamics. So in the next session now I will be discussing about the first law of thermodynamics. Till then, have a nice day. Bye.